Okay, today we're going to be carrying on with our binomial expansion. We're going to be expanding a plus bx to the n. Previously we've done 1 plus bx to the n, which has been fine, but now we've got a here. So make some notes, get your heading, lesson objective and dates in Welsh down, and let's have a look at an example. So this is our first example. Find the first four terms of the expansion of the square root of 4 plus x. Now we can rewrite that. So if we write our square root of 4 plus x here, that's equivalent to 4 plus x to the power of half. Now the issue we have is we haven't got a 1 here, so we can use this expansion normally if we have a 1 as our first term, but we've got a 4. So what we do is, pretty sure you can guess, you do this same thing when you have completing the square. We factorize and we remove the 4, so the 4 comes outside here, and then we're left with 1 plus x over 4. And that's all to the power of a half. Now if we apply the power of a half to both of these terms here, that gives us 4 to the power of a half and 1 plus x over 4 to the power of a half. And that term now I can expand. 4 to the power of a half, that's the square root of 4, which is 2. And I've got 1 plus x over 4 to the power of a half. So I'm going to expand this term to get the first 4 terms. So I've got 2 into, using my expansion from above here. So I've got 1 plus n is a half, so a half, and x is x over 4, half of x over 4, plus a half times a half minus 1 minus a half, all divided by 2 factorial, times x over 4 squared, and I need one more term, plus a half times minus a half, and minus a half minus 1 gives me minus 3 over 2, all divided by 3 factorial, and x over 4 cubed. Close my brackets. So simplify now. So I've got 2 into 1 plus x over 8, an eighth of x, plus, well, let's have a look. I've got a negative here, so that's going to leave me with a negative. And remember, it's better if we work out our terms in the margin here. So if we've got a half times a half divided by 2 factorial, so that's going to be times 1 over 2. And then we got times a quarter squared. That's quite a few. 4 times 4 is 16, times another 4 is 64, times 2 is 128. That's quite a few twos there. So x squared over 128. I've got 2 negatives here, so I'm going to have a plus. And again, working out here in the margin, 1 over 2 times 1 over 2 times 3 over 2 times 3 factorial, so that's 3 times 2 or 2 times 3, so 1 over 2 times 1 over 3, and then I've got 1 over 4 cubed. So just the 3's cancel, and when I work out that sum, I get x cubed over 1024. So for once you can use your calculator. And I multiply everything by 2 now, so that leaves me with 2 plus x over 4 minus x squared over 64 plus x cubed over 512. And that's job done. Now, over what range is this valid? Now if we write here the square root of 4 plus x, so the modulus of x, because we've got x here, is going to be less than 4. And that's the range over which it is going to be valid. Good. So that's one example. Make some notes, and when you're ready to have a look at the next example, hit play again. Okay. Second example is a similar sort of thing. We haven't got a 1 here, so we're going to end up factorizing. But first we have to turn into a term we can use. So we got 1 over 2 plus 3x squared. That's equal to 2 plus 3x to the power of minus 2. If we put our square brackets, we can factorize what's in the brackets first, taking the 2 out. That leaves us with a nice 1 here, plus, I've got to divide by 2, 3 over 2x, and it's all to the power of minus 2. So each individual term then, to the power of minus 2, so that'll be 2 to the power of minus 2, times 1 plus 3 over 2x to the power of minus 2. Now, 2 to the power of minus 2 is 1 over 2 squared, and 1 over 2 squared is 1 over 4, so that's going to be a quarter. This time I'm going to use the square brackets. No special reason, just to be different this time. Then I've got 1 plus 3 over 2x to the power of minus 2. So I need to expand this section now. So that's a quarter times, when I expand it out using our formula here, first term is 1, n is minus 2, so plus minus 2 times 3 over 2x plus over minus 2, and then minus 2 minus 1, minus 3, divided by 2 factorial, times 3 over 2 x all squared. And I need one more term to get the fourth term. So minus 2 times minus 3, minus 3 minus 1, minus 4 over 3 factorial, times 3 over 2 x to the power of 3. And it carries on. So that leaves us with a quarter of, we simplify, 1 minus, the 2's cancel, 3x. Got 2 negatives here, so they're going to give me a positive, plus the 2 factorial, or just 2 cancels with that, 2 there, and that leaves me with 3 times 3 times another 3 over 2. So that's 27 over 2 times 2 over 4 x squared, and our final term then plus, got 3 negatives, so it's not going to be a plus, it's going to be a minus. 2 times 3 will cancel with the 3 factorial down there. That leaves me with 3 times 3 times 3, 27 times 4. I'll tell you what, let's work it out over here. It'll be 4 times 3 times 3 times 3 divided by 2 times 2 times 2. Marvellous. So those 2's cancel with the 4. Leaves me with 27 over 2. So it'll be minus 27 over 2. It's interesting. Got 27 both times, but this one's over 2. X cubed. Now if I multiply everything by a quarter, I get a quarter minus 3 over 4 x plus 27 over 16 x squared minus 27 over 8 x cubed, and that's our expansion. So all done, except I need to find a range for which it's valid. Now in the last one we used this part of the equation, but we can also use this one here. So if we look at that, let's write it up here. So valid for, if I look at 1 plus 3 over 2x, so the modulus, I take the 3 over 2x and put it here, 3 over 2x is less than 1. That's an x, by the way. Now if I get the x on its own, that means I'm going to multiply by the 2 and divide by the 3. 2 goes up there, and that's our solution. The modulus then is going to be less than 2 over 3. I could have used this expression here, 2 plus 3x. So put brackets around them. Then the modulus will be the same, because I'm going to put a modulus of 3x. It's going to be less than the 2 there. To get the x on its own, I'm going to divide through by 3. So the modulus of x is going to be less than 2 over 3. So whichever way you do it, you come up with the same solution. Here we are, 2 good examples for you. So what I want you to do now is write that down and then get some practice in. So hit pause, make your notes, and when you're ready, I'll put some questions up for you. Right, questions for you. Question 1. Make sure you attempt G. Make sure you understand how you can change it from 1 plus x over 2 plus x into 1 minus 1 over x plus 2. And you've got a few more questions. There you go. Good practice for you. Number 5 looks like a good question. Okay. Good luck. Off you go.